Hello, ladies and gentlemen. This is Mr. Waters, and this is another edition of Honors Algebra 2 coming to you from Waters Studios. Okay. Today we're going to be continuing our series of videos on sequences and series, and today we'll deal with geometric series of different kinds. Okay. However, first, before we do that, I want to go over our homework, okay? We had a couple of problems on the homework that I want to discuss with you a little bit before we start in on the new material. I should tell you that this is going to be our last, well, I don't know if it'll be our last lesson, but we're coming up fast on our next test, which will be on geometric sequences, which will be, on sequences and series in general, and we'll get more information out about that soon, okay? So let's see here. Okay, so here is the homework. I checked the homework here, and one of the problems checked was number 10, and another one checked was number 18. So we're going to go over those two. I hope that you are taking the opportunity, once I've graded the homework, and it's gone back up onto a canvas, that if you didn't get 10 out of 10, that you're going back and you're looking to see where you went wrong, and what your mistakes were, okay? Anyway, so we're going to do this problem here. Number 10. It says, given two terms in an arithmetic sequence, find the common difference, the first term, and the explicit formula. Okay, and here it says we've got the 11th term, which is 138, and the 38th term, which is 408. Okay, so I'm going to go ahead and I'm going to put this got this already written out fair and square for us here, mostly, on a separate sheet of paper. And so here you see, here are the two terms. We've got A11, 138, and A38, which is 408. And what we've got to do is we see that what happens with an arithmetic sequence is we're jumping, a certain number of times to get from 138 up to 408. And each jump is equal to what that D value is, the common difference we call it, right? So we do a calculation here to calculate how much each jump is, right? So we know that we're jumping from 138 up to 408, so we subtract, and we jumped a total of 270 units, and we jumped from position 11 up to position 38, so we subtracted that, and we see that there were a total of 27 jumps. So we divide 270 by 27, so each jump had to be 10, okay? So that's a handy-dandy little formula that you can use in order to calculate how much D is. So now that we know what D is, we're going to go ahead and write that up here, right? There it is. 10 is D, okay? And then also the next part, now we can get A sub 1. Okay, we know that that the 11th term is 138. Okay, so we can plug in here. We know that this is our general formula for any arithmetic sequence, our explicit, the template, the format for the explicit formula of any arithmetic sequence. So we can use this to solve backwards for what A1 is. We know that D is 10. We know that the 11th term, right, is 138. So I just plunk in 138 for A11 in the front. I put 11 in for N, and so 11 minus 1 is 10, right? So we can now solve for A1. 10 times, you see here, 11 minus 1 is 10. 10 times 10 is 100, right? Subtract 100 from both sides, and we get A1 is 38, okay? So you just got to make sure you're using careful algebra on that kind of thing. So therefore, as we can see here, A1 is going to be 38, right? Okay, 38. Okay, so then the last part is to figure out what the explicit formula to generate any term in the sequence. Okay, so I just use this format, plunking 38 in for A1 and 10 in for D. right? And then I just, again, using careful algebra, I multiply through the 10 to get rid of the parentheses. And then see, I can simplify 38 minus 10 is 28. So right here, that's our formula. And you can see that we can check to make sure we're doing it right. Because here the 38th term is supposed to be 408, right? So I'm going to plug in 38 into this formula for n, and if I'm doing it right, the answer should come out to be 408, right? Okay, so, yep, 10 times 38 is 380, plus 28, yep, does give us 408. So that checks, okay? So therefore up here, I'm going to write in the formula is 28 plus 10n. And you notice that d value is that multiplier there, the slope of this linear equation that we just generated. Now the other one, number 18, is right here, and it says we're supposed to evaluate the arithmetic series described, right? And it's given to you in sigma notation. Okay, and so down here, okay, so I've written it down here. So it's sigma, okay, 6m minus 1. So this says that we're going to add up the first 9 terms of the sequence. M is going to count up from 1 to 2 to 3 to 4 to 5, 6, 7, 8, 9. And you're going to generate, one way to do this is we could generate this series by simply calculating what the 9 terms are and then adding them together. So the first term, as you can see, would be 6 times 1 minus 1, which is 5. 6 times 2 minus 1, which is 11. 6 times 3 minus 1, which is 11, right? I mean 17. 6 times 9, 54 minus 1 is 53. So you see the series would look like this, plus dot 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 plus and then 53. So the series means we're going to add up the first 9 terms of that series. So this would be the expanded version of the series if we wanted to write it that way. But we're asked simply to evaluate this series, which means we're supposed to get the sum of the series. So we could, if we were just wanted to do an awful, extra work, we could go ahead and calculate what all 9 terms are and then simply add them together. But we don't have to. There's a shorter way to do that. We had last time 2 different formulas for the sum of an arithmetic series, so long as it was a finite sum and we knew a finite series, and we knew how many terms there were in the series. So it was this one here, n divided by 2 times a1 plus an, where a1's the first term, n's the number of terms in the series, and an was whatever the last term in the series was, right? So if it was 9 terms, this says that we're adding up 9 tens and 9 terms in the series. So n would be 9. So this would be a sub 9 right here. If we knew the first term in the series plus the number of terms and d, the common difference, we could also use this formula here, right? Okay, so either one will give us the correct answer. I personally used this formula here, right? So I put 9 in for n because there are 9 terms in the series. A1 was 5, A9 was 53, and then we crank on the calculator to get the answer, and that works out to be, that's 9 over 2 times 58. That works out to be 216. Okay, so that is the sum of the series, and you would have gotten 216 if you would use this formula as well. Okay, in this case you can see that the common difference is 6, so it would be, in purple, 9 over 2 times 5, because that's A1, plus 9 minus 1 times the common difference, which we can see is 6, right? So this is 10 plus 8 times 6, and all multiplied by 9 over 2. And if you work that out, that still gives us 216. So either formula is correct, and which one is easier depends on which, kind of which information you've got. Okay? All right. So let's see. So that's about 10 minutes in. This is the homework we had. This is from the last homework. So the next video will be the video about our new lesson, which is about geometric series and the sums of geometric series. Okay? All right. Stay tuned.